So if you have any question, please feel free to put your question in the chat window. So tonight we're going to have a interesting topic. One will be started by Paul. Paul is from Hanson. He's been doing the a very senior ABAP developer working in SAP since so 1997. So tonight he will be presenting the topic Hanson DMC Project, translating a complex material science problem into algorithm inside SAP. Just want to set the expectation right. Paul will not sharing a secret recipe from Hanson. He will be sharing his knowledge in SAP ABAP point of view. Just make sure everybody have a right expectation. The second session will be a classic workflow and flexible workflow in S/4HANA in customer journey. So that will be presented by Archana Sukla and Bernard Knut from SAP. So in that session, we're going to listen a presentation, what we're going to do with the existing SAP classic workflow, and what is the decision when we need to move to a flexible workflow. So I would like to start this event. So I'll hand it over to you, Paul.
Okay. First of all, I'm going to start sharing, and then you've got to tell me if you see the proper screen or desktop or the screen with the notes. That's what I want. What can you see?
Screen with the notes.
Okay, that means I've got to press the button to swap. No, that's not the one.
Presentation mode.
Yes, but there's a button to
Cool.
Right. Can you see the notes or not?
Yeah. No, all good.
You can't. So you can't. You can just see the screen. Is that correct?
Yeah, that's the screen. Just the screen.
Me drinking beer. Okay, that's good. Okay, well, I'm ready to start whenever you so desire. So I'll start. Okay. My name is Paul Hardy. I'm English, but I've lived in Australia since the year 2000. And I'm here today to talk about something called dynamic mix configuration, which is all to do with concrete. Before I start, I want to tell you about a little contest that's going on during my presentation. At 4 points during the presentation, the Eggman will appear, each time with a word. You've got to note down all 4 words, and then afterwards, the first person who gives me a direct message on the SAP community website with the 4-word message will get a mystery prize. Now is the time to get on with the real presentation. What happened a few years back, Hanson was nominated for Australian prize for the most inventive IT project of the year. Sadly, we didn't win. We were pipped at the post by Woodside Petroleum, who interfaced robots they got from NASA into SAP, which I don't know, that's far too groovy, unfortunately. More interesting than concrete, perhaps. But there we go. But we came second, and it's certainly a worthwhile thing for me to talk about, and that's why I was asked to talk about it at this event. DMC, as mentioned earlier, stands for Dynamic Mix Configuration, which is our word for SAP variant configuration. Going to talk very, very briefly about the company I work for, and then the standard presentation format, where we started, what we did, and the benefits going forward. Heidelberg Cement is a multinational company which operates in about 50 different countries and has 70,000 employees and makes building materials. We don't build anything ourselves. We supply concrete and cement and aggregates and so forth, but most people don't really care about that. What they do care about is how it relates to them, which is we run SAP, the same as your organization. We've got loads and loads and loads of Z code, like most organizations. And one day in the very near future, we're going to have to move to S/4HANA, just like most organizations. None of what I'm going to talk about is going to make a lot of sense until I talk about what exactly is concrete. I'm sure the gentleman from Holcim will know, but many people don't. Because most people think concrete and cement are one and the same, because they both look grey, but in actual fact, they're two completely different things. Cement is an ingredient of concrete. It's the glue which sticks the rocks together, forming the hard material, which is concrete, and it's what gives concrete its grey colour. Cement gives concrete its grey colour. Also, people would think that concrete's all the same because it looks the same if it's on the floor or in a bridge or in a building. But in actual fact, every mix of concrete is different. The example I always give is German beer. In Germany, because of the purity laws, you can only have 4 different ingredients in beer, one of which is water. Yet you have 10 billion types of beer, all tasting different. Concrete's the same, only a few ingredients, one of which is water, but every mix is totally different. That's concrete. What about cement? Well, cement is the powdery stuff that goes inside concrete. Going back 2,000 odd years, the Romans used to make concrete, and they got their cement by going to volcanoes. The reason you need a volcano is because to make cement, you need an incredibly high temperature. You mix various chemicals in a very, very hot environment, and boom, out comes cement. So these days, we don't go to volcanoes, strangely enough. We use kilns and heat them up greatly. And as a byproduct of that, we let off a lot of carbon dioxide. In fact, Heidelberg Cement, as a global organization, puts out 0.4% of all the man-made carbon dioxide emissions in the world every year. And that's quite a lot. So we realize it needs to change. Going back to the world of SAP, how we used to make concrete, we had what's called fixed materials. Each mix of concrete had a record in the SAP Mara table with a fixed BOM. We had a lot, like thousands and thousands of different concrete mixes. But the problem is one size does not fit all. As I mentioned earlier, basically every customer wants something subtly different. So we'd have to give them the closest fit. And that would be the closest fit which was strong enough. And that meant that 99% of times, just to be safe, it had to have more cement in it than was needed, just to make sure the building isn't going to fall down. Other problem we had is we've got lots of concrete plants all over Australia, like 250. And we've got to make sure that the materials are extended to every plant that can make it. And if we fail, then our optimization of trucks will say, oh, this plant can't make it. So a customer will get supply from a plant a long way away rather than a plant that was nearby. It sounds trivial, but it's a big thing, as you'll see later, if it's trucks going much, much further than it needs to. In the slide here, you see a little plant right by the customer and a plant further away. The truck's going further than it needs to go, a lot further, because the material hasn't been extended to the plant that's near the customer, even though it can make it. So these are the problems we had. We decided to not completely reinvent the wheel and do what a lot of companies that have make-to-order products do, and use SAP variant configuration. So the DMC project was started. That's our name for variant configuration. And one thing about our company is it's always standard SAP at the heart, but we always wrap it in loads of Z code, because standard SAP, as you may know, is not very user-friendly. On the left of the screen, you see the standard SAP variant configuration screen. It's not very nice for the end users. It does everything that's needed, but it takes ages to enter the data. The F4 help is bizarre, to say the least, and the error messages are very, very cryptic. So we overlaid that with some Z code. It's still the standard SAP, 100% standard SAP behind it, but instead of strange F4 behavior of the standard, we have buttons people press based on what the customer says. And with each decision the customer makes, the buttons rearrange themselves to make the possibilities are restricted, and once it's restricted enough, right, it's finished, and it works very fast. These are all based on user interface rules, but by our technical department. And rather than having IT maintain these rules, we've given them a sort of self-service, because they know better than programmers which combinations of concrete materials work best, and they maintain it themselves. The second problem with standard SAP VC is it's a black box. Generally, with a standard implementation, you being the user, put your data in, something happens in the background, and the data either all changes, or you get a green light, or you get a funny error message, and you don't really know why. So what we've done is, if someone's puzzled and understands enough about concrete, they can press a button and they'll get a very, very detailed log of what's happening in the background. Every single step, and there's thousands of steps, are logged. And the good thing about that is that you can see where the error message is, at what point in the process it's happened. And furthermore, from the technical people, they can determine if there's something wrong with the entire process, because it's not hidden. It's not hidden in the guts of SAP inside code. It's 100% visible. I'm always talking about automated unit tests, and I built this in a completely test-driven development manner. Each step in the process isolated into its own routine, and wrote a test for it before I went on to the next one. This means the thing's very, very stable, because every time we make a programming change, we can run all these unit tests and know we haven't broken anything, which is very important when you're talking about bridges and buildings, which you really don't want to fall down for lots of reasons. I'm also obsessed with performance, and I've managed to make this incredibly fast, so much fast it can evaluate 10 different possible plans for supply in under a second, which is very important. The next bit is all to do with the what-if analysis. I've got the unit tests for the programming, but oddly enough, the programming is only half of it. The other half is an incredibly complicated data model based of a vast amount of custom configuration tables. Now, those are looked after by our technical team, the people who test the concrete and look after the rules of designing mixes. Now, they're the ones who change the configuration data. And again, we don't want to make buildings fall down, and we don't want to invalidate orders that have already been taken. So we've got this transaction. You might wonder what a dinosaur is doing there. It's called, our transaction is called ZDino because all the variant configuration transactions are named after Flintstone characters. Don't ask, that's just the way it was. But anyway, the point being is one of our technical people decides to make a change to some configuration. It gets stored in a temporary table. They can run a simulation to see what it's going to affect. And, you know, they get warnings if it causes something dangerous or futile to happen. And it needs to be approved by a manager who can also run a simulation. So on that ball number 3, the simulation is run using the change data and the actual real data to merge them together to see what will happen if the change goes through. It's a safety net. That's the size of this. And this all sounds simple, but it took many years to go to get this right because it's incredibly complicated. And what were the benefits that we got from doing this in the first place? Various people are happy. The customer, which is naturally the most important, are happy because it's a customized solution. The concrete is now a made-to-measure product. Before, we were giving it the closest fit that would meet what they were asking for. Now we can give them exactly what they're asking for. It's no more and no less. The second bit, our customers are not much for online ordering. They like to use the phone. This may change in the future, but at the moment, no, it's all phone calls. And people want to stay on the phone for the shortest time possible. We're already pretty good at this. But this makes it even faster because the person taking the order doesn't have to search for the closest fit. They've just got to listen to what the customer says, press some buttons, and boom, the result comes up. It's a minute less on the phone. Sounds like nothing, but it makes the customer just that little bit happier. And means we can take more orders as well as a side effect. The third benefit, as I mentioned earlier, what this means is we don't have that problem anymore where materials have not been extended to plants. If a plant can make it, the DMC algorithm will know about it. So that means if there's a plant next to the customer, that's where it gets supplied from. This was a big problem for us. Trucks going too far. Now it is not. That means the truck's got a lot less to travel. That means much less chance of it getting held up in traffic by an accident or traffic lights or the myriad of things that can happen when a truck's on its way. So it's much more likely the truck will get there on time. We're happy, of course, because it saves us money. This is the whole idea of having a giving the customer a better product that costs less to make, what you call a win-win situation. From us, the training costs are less because before the order taker had to know a little bit about concrete and the way it was made. That's what usually happens in BC variant configuration implementations. You've got to know a little bit about it. Here, we've got buttons. So the training basically involves press this big button based on what the customer has just said. It's a lot easier to get new order takers on board. Second benefit for us is less cement. Cement's by far the most expensive ingredient in concrete. Now we don't have to have excess cement in every single order, it means we use a lot less, so it costs a lot less, without compromising safety and without compromising product quality. So, as I said, a better product, it costs less to make. That's great. The third one, going back to the trucks having to travel less, means the fuel costs are less. We can either deliver the same amount of loads with less trucks, or anyway, it's cheaper, less fuel costs. And the third person who's happy is the entire world. The reason being is because we're not using as much cement, so you don't need to make as much cement, so you don't put as much carbon dioxide in the air. The second point is the same with fuel costs. The less you're on the road, less fuel you use, the less tailpipe emissions. And this is all just the start. The concrete and cement industry is perceived as being evil for pumping out all that carbon dioxide. So we start with tracking, which we've been doing for a while now, very accurately. Now we're trying to avoidance, which is, again, what DMC is about, to avoid the use of cement where it really isn't needed. And in the future, we as Heidelberg Cement have a load of experiments all around the world to capture CO2 from various cement plants. And eventually, when technology allows, we'll be able to replace cement with perhaps something more friendly. This is speculation, but again, experiments are going on. Now, this basically brings me to the end. I shall go to a summary and then have some question and answers before the next people. As I said, it saves the world a little bit. At least it doesn't make things worse. It saves the company a lot of money, better product, and even though it's standard SAP at heart, because of our fiddling, it's made it very user-friendly. That's all I have to say at the moment. I look forward to answers now, and this presentation will be made available afterwards. And of course, any questions that aren't handled today can be emailed to me later.
All right. So thanks, Paul, for the awesome presentation. I can see Paul also sharing the KFC burger and everything. That's probably the takeaway for all of us.
Yes.
So I do have I think one of the audience here have a question. How do you manage demand and forecasting to so many recipes?
So we're talking about the costing of the materials we're talking about.
I believe so. That's a question that I can see here. How do you manage demand and forecasting to so many recipes?
So we've got the forecasting, the so-called MRP, Material Replenishment Planning, I think that stands for. We've got that running every few minutes. Basically, but these bombs can explode so fast that literally every 5 minutes we have a batch job running that looks ahead for the day. We don't have to forecast for more than a day really, because the orders change so quickly. And we've got every 5 minutes we recalculate the demand for the rest of the day at various plants, and we've got this optimization system called SynchroTest, which it feeds into that, and the plan is recalculated virtually constantly to make sure that no plant will run out of raw material to supply the and this is quite important because if we got 7,000 orders for tomorrow, half of them get cancelled during the day and another half come in. So everything's changing constantly.
Okay. So yeah, this presentation, it looks very scientific, Paul. I was wondering how long this project, how long this project been executed, Paul, from starting from the planning until live in the system?
It took 4 years, I have to say.
Wow.
That's 4 years where I spent going to Brisbane every Tuesday. I'd fly to Brisbane. Every Thursday I'd fly back. Every evening I'd fly back. What was happening? I was just one of the team. I was a lead programmer. I did virtually all the programming. But what I was doing is, one gentleman had been designing concrete for his whole career, and before he retired, he wanted to move the contents of his brain outside of his brain and into SAP. And that's what my job was.
Okay, so that's 4 years full of how many, may I know how many resources on this project, Paul?
There's probably there was, I don't know, let's just say, I don't know, I was full-time. There's probably another 2 programmers full-time, but if you averaged it out, doing other little bits, and 2 or 3 business analysts, one on the technical, one on sales, one on logistics. Okay. So it cost a lot of money. There's no doubt about that.
Yeah.
But the idea was that it was supposed to save $500,000 every month, which it did. Right. So quite it's a big cost up front, but it paid back for itself very quickly indeed.
Yeah, I can imagine a lot of scientific formula behind your code as well. Was wondering how you optimize the ABAP code itself, Paul.
That's right. Well, it's a big obsession of mine, getting things fast. The most important thing is having all the configuration tables buffered, so you don't get no database access.
All right.
That's the really most important thing, because SAP is very good, like all computers, at calculating things. The bottleneck is the database. If you can avoid any sort of call, or at least repeated calls, that's how I can do 10 bomb calculations in a second.
We have one more question here, Paul, and probably this is the last one for your session, from Marcus. Marcus said, I'm always struggling with the mocking of the data in SAP, for example, the big business partner data model. Maybe you can give some question about mocking data?
Yes, I did this because, as I mentioned, I did this in a test-driven development way. And I did the database. I created the database tables, the actual real ones, last. What I would do is I'd write for each step of the process, I'd write the code, and then I'd have a mock database access class, which came up with completely hard-coded values, which I copied out of a spreadsheet. The tables weren't even there. I hadn't even created them. So when it was being designed, the data was 100% mocked. There was no real database access at all. It was all faked. It was only after I knew that the algorithm worked that I started changing it to read real tables, as it were.
Okay. All right. Sorry, Paul. One more question. This is the last one, I promise. So moving to S4HANA, is someone asking, so moving to S4HANA in memory database will not require the buffers. So what will we need to do with your legacy ABAP code?
Look, the code will be exactly the same, really. It'll still be buffered. And a little known fact is, even in S4HANA, even in an in-memory database, it's still faster to read from the buffer. So that's a little known fact. People think, oh, everything's in the buffer, but it's still, even in S4HANA, it's still faster to read from the. It'll just be faster from the very few times that I do have to read. At the start, you read the material data and assorted things that are absolutely necessary, like customer data and plant data and things. At the start, that'll be faster in S4HANA. It won't really be dramatically different, though. I have to say we've got the benefit already.
Okay, all right. So thank you.
Sorry, question.
Yeah, sorry, Murli.
No, sir. Murali, it's Dave. Paul, are you planning version 3 of your book?
I'm writing it as we speak.
Excellent. So I've bought both the first two. I'll look forward to that.
All right. Thanks, Paul. So for the benefit for others and just a bit of promotion for Paul, Paul Hardy is actually the author of 3 books so far from SAP Press Book. The first one is Up to the Future. The second book, Migrating Custom Code to SAP S/4HANA and Refactoring Legacy ABAP Code. Yes, Paul is a very famous ABAPer in SAP world. We are very fortunate to have Paul in this evening event. Thanks again, Paul.
Okay, I should now switch my sharing screen off. There we go.
So the next
And your
session...
message is get off the piano.
Tut. I hope the first person who sends that to me,
I did send it. It's in the meeting chat.
Well, that's not good enough. I said the rules. You've got to follow it.
All right. So we going to a bit of a break, probably 10-minute break before we get into the second session, which is a classic workflow and flexible workflow in S/4HANA. So I'll give you about 10-minute break for everybody to do a bit of cup of tea or something else. All right. See you in 10 minutes.